This is TWIS. This Week in Science, episode number 772, recorded on Wednesday, May 6th, 2020. Celebrate the science teachers. I'm Dr. Kiki. Welcome to TWIS. Today we will fill your head with effectiveness, thanks, and commonality. But first, thanks to the Burroughs Welcome Fund and our Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. Science! It's the one thing upon which the world is now relying to make civilization possible again. While there have been significant advances in all areas of science over the past several decades, while technology can cross continents instantaneously, oceans too, to keep loved ones in contact, while new medicine can slow, prevent, and even cure illnesses that once were swift and deadly, while we have discovered new planets, unraveled mysteries of human origin, and learned so much about how our natural world functions, while the fundamental way in which the physics of the universe is constructed continues to tell us stories through super colliders, supernovas, and super cool space probes, the one thing that we could not do is remain vigilant to a threat, while novel is anything but new. Our current predicament was not unimaginable. It was imagined. It was warned about, and not for nothing because it's happened before. We humans rely so much on science that it seems as though we've gotten to the point where we're beginning to take it for granted, as if discovery was just a natural progression of time. Wait around, new stuff will just show up, fix everything. As if there's a separate world almost. A world where all of us normal humans go about our day-to-day business. And then this other world of super adulting scientists who are focused on the troubles that might present themselves to the world with all of the resources they need to anticipate, complete research, and avert tragedy. And in a way, that's true, except for the research funding part. If we take one lesson from this threat, it is that research, not rhetoric, creates the security of this country. That academic insight, not just military might, can keep our borders safe. And maybe most importantly of all, that This Week in Science is coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again to bring you science because we love talking about science. We love learning things and asking questions and digging into the universe. So good. And yeah, 2 universes? What? 2 worlds? No. We are one. We are connected.
We are on the same planet.
We are on the same planet. Thank goodness for that. And we have a bunch of stories for everyone who is here on this planet with us and wants to share in the science with TWIS this week. I have stories, about heavenly bodies, dark ones and gassy ones. And I also have mushrooms for people. Because that's fun.
Oh, okay. Well, save those for later. We got to get through the show first.
All right, I'll save them for later.
Let's see.
Justin, what do you have? Yeah.
I've got smart research into making more effective viruses as well as wireless car charging thing.
We're going to have smart viruses that can drive themselves wherever they want. Great.
or fly, actually.
This seems like a Target shopping list. Okay, I need mushrooms. I need a car charger.
Wireless car charger. Let's see. Mushrooms and and then maybe something else if the show runs short.
Okay. And Blair, what's in the animal corner?
Oh, I have dolphins, salmon, and koalas tonight.
All the animals.
Yeah.
We love them. These are Because, I mean, salmon, we like to eat them. We wouldn't call them cute. Dolphins and koalas. Those are cute ones.
I mean, some people might find salmon cute.
They are if you catch one. Then you're like, oh, people take pictures with them. Like, look at me and my fish.
And their little baby
Look at me.
fries, perhaps. They're cute.
Look at me and this
Or
dead
they
fish
make
I caught.
their little fish faces. Oh, salmon.
Or make a fish face.
Yeah, the little baby fishes are cute to their
that's
parents.
not bad.
As we jump into the show, I want to remind you that subscribing to the TWIS podcast on your favorite podcast platform or on YouTube or Facebook will bring you twists every week. That's right. We make a new show every week. And if you subscribe to us on these platforms, you will find us more easily. So just look for This Week in Science if that is something that interests you. You can also find us at twis.org, our website. But now it's time for the science. All right, jump off the dock and into our COVID update, because that is something that's important to do, to just get it out there for everybody. Get this big news off of our chest for everybody, because we're still in this together and we are making our way through it, even as our governments try to open our economy and bring people back to work. Hopefully we are able to do that in a safe manner. And that is what a lot of the conversation is about these days. Numbers of dead and infected continue to increase around the world. But the science is something that's important for us to focus on. Number one, we want to focus on the way that science can be sensationalized, because very often the media can pick up on things and run with them. And that leads a lot of public dialogue that is not useful and can, in fact, be harmful. So we need to be very considerate of the sources of the information. And I just want to reiterate for people to beware the preprint. Preprints are awesome for the scientific community, and they are wonderful for the fast turnover of scientific ideas, because scientists are able to get their ideas out faster, have them shot down more quickly by the scientific community. Errors can be spotted more quickly. And we've seen this all along with COVID-19, how it's progressed, that preprints have been a little bit of an issue. But recently, the LA Times published on a preprint in the bioarchive from a group of very well-established scientists about their work looking at the genetics of SARS-CoV-2 and mutations in the virus. The LA Times ran with the headline that said that a study found that mutations are increasing the infectiousness of SARS-CoV-2, of COVID-19, that these mutations are leading it to spread more quickly. And not just the LA Times published it, lots of other people jumped on it. And so suddenly everybody in the world is going, oh no, this is a bad thing. We're going to get it more easily, when in reality, it was published on a preprint archive. And as soon as it was published and people got wind of it, they started to tear it apart. And there are many criticisms of the research, in fact. One of which is that a lot of it is correlational, and it could simply have to do with the data set that they're looking at. And they are finding this mutation in places where there are lots of cases, where there are lots of people, just because that's the way it's spread, not that it has increased or is increasing in infectiousness. So anyway, there are multiple criticisms of the paper, yet the sensationalism through a headline is what gets to people first and can lead to a lot of the perceptions by the public. So I just want to reiterate to our audience how important it is to look past the headline and to also look past the major media articles sometimes and look for more experts, and make sure that the studies that you're talking about are peer reviewed, because that it is one additional level of certainty that you have in what you're seeing in the science.
And if I can add to that, I think directly related to that is people grabbing news stories from social media in which the headline is read or digested and that's it. So that's kind of the other side of this too, right? Is sometimes the reporting could actually be quite good, but because
it's the headline,
it has the sensationalist headline, that's all people take away from it. You know, I'm immediately I'm thinking of the murder hornets that were on the internet this week. And when they're called murder hornets, actually what that means is that they kill bees, not humans. And so of course people read that and thought that murder hornets were killing humans.
Coming for you. It's so, like it's the COVID-19 version of the Africanized bees, right?
Right.
You know, is the killer bees, the murder hornets.
Yeah.
Yeah. They're coming. They're all coming for you. Yeah, but yeah, take it with a grain of salt.
Read it.
Look
at the source.
So there's a convenient thing too. There's a very convenient thing, which is that all research is conducted by humans who have names, and those humans with names who have degrees are doing their research at institutions which also have recognizable names. You see where I'm getting here? So there are publications that are doing what you're calling the peer reviewing, not just this. And I think these first paper things are coming out now just because of the rush and the buzz, and people are throwing things out there trying to share it to other researchers. This isn't normally the way this is done.
Preprints are used very often. They're gaining popularity. They've been used in physics for a very long time. But in biology, they're gaining popularity. And but they're throwing it out there for other scientists.
Yeah. Yes. But then if it's in a publication, there's also likely people who have reviewed it or who can review it and who've looked. There's a whole bunch of really easy steps to having vetted information if it comes from science. Names. And if you ever hear claims like, you know, that it was too far advanced or for anybody else to be understanding or commenting on it, that's ridiculous. If it's so simple that scientists wouldn't deign to go down to that far and consider something like, stop. Like, don't believe any claims. Just look at names, institutions, publications. If you have that combination and a date. Because I can tell you, there is a study that I didn't bring tonight. There's a study, I didn't bring it tonight, that shows that tobacco is actually very effective against tuberculosis. Now, no, it's a real research paper, but it was published in 1909.
Right.
So it also matters when the research was written. That's also very important. If it's 1909, not that it wasn't published by a leading scientist in 1909, but maybe there's been more added to the story since then. So how recent.
So have you ever seen, there's an old skit with Bob Newhart from Saturday Night Live where he is a therapist and his form of therapy is just telling people to stop it. They start talking about their problems and he says, okay. Stop it. That's his therapy. They're like, but why do I stop it? And I feel like if we could just, when it comes to media, we just remember to stop it, look for the source, the timeliness, the objectivity, and the publication.
Yes, I love it.
Stop it. There you go. Just follow Bob Newhart.
I want that tattoo. That's a really good one.
Just stop it. Source, timeliness, objectivity, publication. It can help every time. All right. Moving on from there, though, there is another study looking at the genetics of SARS-CoV-2 that is published this week. It's available online. It's a journal preproof for Science Direct and from Elsevier. And in this study, they look at a number of sites in the SARS-CoV-2 genome, and they look at how it transmitted around the globe, seeing that there are several places in which there have been reintroductions over and over, so that there are multiple genetic lineages, maybe in Washington State, because lots of people came from different places where their particular infection happened to originate. And they have found deleted recurrent mutations that might indicate ongoing adaptation of SARS-CoV-2 to us hosts. And they recommend that we should continue to monitor these patterns of genetic diversity. But it doesn't come to any kind of implications of whether or not it's becoming more infectious or less infectious. It just, they have a number of new mutations within various strains that are of interest and that could be points for treatments or targeted drug treatments that we could develop at some point. And so checking out these mutations is very important to, yes, figure out how it's adapting to us and whether it's adapting to us in a way that will cause a worse outcome at some point, or if we can use it to our advantage.
Symbiotic. Or if it's becoming more symbiotic. Well, I mean, and not symbiotic necessarily, but like they do something with the coronaviruses don't kill bats. MERS doesn't kill bats.
Right.
The SARS doesn't kill bats. And
as we talked about last week, parasites do a better job if they don't kill.
Yeah, and the virus is probably doing something, as well as the bats also probably doing something to make that relationship work. Now, maybe if I've done this over a very vast amount of time, I don't know. But I wonder if there I don't know enough about virology to know if there's a case out there of a virus that entered society, was trouble, and then became sort of just normalized, endemic, less harmful.
Right.
Yeah, endemic.
Yeah. That's an interesting question. So, within human history, it would become less harmful, not necessarily because of our medical adaptations, but because it adapted to become less harmful to us.
Yes, because you could suspect that maybe not completely lethal, because that would sort of turns into a dead end there anyway for transmission, but something that caused illness, that then the really sick people were less likely to interact with others, and the versions of it, the little mutations of it that were less hindrance to catch, persisted and spread more and continued into society. It'd be kind of interesting to know if that's know of an example. I mean, it must have happened.
I don't know of an example, but that's a great question.
No,
I hope
I don't know if we haven't known about viruses really that long in terms of modern science. So I feel like
animalcules.
Yeah, even looking at other animals and viruses and stuff, I'm not sure that's something that we've been looking at long enough to really be able to catch. Because unless it's killing things, we might not even have known to look for it.
Yeah. Another study that we need to keep an eye on, and there have been a few of these where researchers are starting to do retrospective analyses of patients that may have had an odd case of pneumonia or other respiratory issue back before January or February. Even reports from France of a case that they looked at, they've retrospectively diagnosed the patient as having COVID. But once again, researchers are criticizing the study and saying that there are critical flaws with the methodology of the retrospective analyses, and that there's a lot of there could be a lot of issues with even contamination of the sample that they used for the study as just one of many. So once again, a single case being retrospectively diagnosed as having COVID-19 is not a study per se. It's not an analysis of multiple cases. And until we have really well-controlled analyses, we should not be making any conclusions about whether or not COVID has been around since before January. It could have been. I mean, it absolutely could have been.
This is the trouble with the COVID research is kind of the combo of these two stories, right? Is that we want to move things forward as fast as we possibly can. We all want to get out of our homes. We want to get the economy going. We want everybody to go back to school and all this stuff. So I understand there's an urge to accelerate processes right now. And in some cases, that's probably something that needs to be discussed and there's things that need to be streamlined. Absolutely. But that is not universal with everything with the word COVID in it, because there are really negative things that can happen from us skipping processes in checking on science and making sure things are correct and repeatable and all this stuff. It's kind of the catch-22 of it all, right? We want to do it fast, but we want to do it right.
Yep.
Yeah. And so this might take 20 years.
It could, who knows? But in the meantime, we're working on it.
I meant that literally, though. I meant, because you were saying, Blair, that we haven't been studying perhaps viruses to the degree that we've been studying bacteria and other fauna on this planet. And it's not as big of a field. Boy, I bet there's a lot of kids who've been missing school lately.
Yes.
Who want to figure out what this virus thing is all about.
Keeping them out of school.
And want to do something about it. I think the next generation of virologists are going to have a lot more impetus, I guess, a lot more inspiration, perhaps than virologists of the past.
I like that. That's a good silver lining.
Silver lining.
Yeah.
Another question is about the accuracy of some of the tests. We talked last week about antibodies and their accuracy, and we discussed one particular test.
Negative.
Yeah, the false negatives and false positives. Well, since last week, the FDA has even turned around and reassessed the way that it allows companies to come out with their tests for the public, and the regulation is becoming a bit stricter. There are some 200 tests for serology, the antibodies that show whether or not you have been infected or been exposed to SARS-CoV-2. And there have been a few more analyses, one of them from a group called the COVID Testing Project.org out of UCSF they've independently analyzed a number of the ELISA tests and also the fast strip tests. And the ELISA tests take a much longer period of time to run, but they are supposedly much more accurate and can give information on viral load, or in this particular case, the antibody, the number of antibodies, or how many antibodies are showing up. There's kind of if you're looking at the signal under fluorescent light, you have a brighter glow. If there's more antibody or less, there's a less of a glow. And then for the strip tests, it's kind of like a pregnancy test. It's either you got it or you don't. And now those are really quick. And the question is, they're the two variables of specificity and what's the other variable? They're accuracy.
Is it precise or is it accurate?
Exactly. That's pretty much what it is. Is it precise or is it accurate? And there are these two variables that are being looked at, and the FDA wants them to be within particular bounds. And if the precision or the accuracy is within these particular bounds, then that's great. But otherwise, and because it's going to limit the number of false negatives and false positives. So right now, though, they're finding that a lot of these tests aren't working very well. And from the COVID testing project, they've discovered that many of the tests are really not good early in the exposure. So if you're getting these tests after you've maybe 5 days into having been exposed, it's not going to show very much. And they do a lot better after about 15 to 20 days. So there's there's a time aspect to how long you've been in contact with this virus that affects the outcome of these tests.
Yeah, which is really strange too, because I've also heard that the viral load is higher before you show symptoms. Is at its highest point before you've started to show the symptoms to it, which would indicate that it was happening. That was happening earlier on. But I guess the antibodies show up later, much later.
Yeah.
I don't know.
Yeah. And there's a difference in which antibodies. So the IgMs or the IgGs. IgM show up much earlier. IgG, which is one that is hoped to confer immunity, is one that shows up later. So there's there are a lot of aspects that are
Why are we still hoping? How do we not know of anybody who's gotten it twice?
There are reports of people having gotten it twice.
Okay.
Lots of,
Then that sounds like there's not immunity.
Well, that's the question. But there are not a lot of those. So the question is whether or not it's individuals who are just not clearing the virus and having it resurge.
Oh, interesting.
Yeah.
Or if they even had it
and there's no way to tell the difference. Yeah.
Or if they even if they had the flu the first time, it was called that because nobody tested.
Right.
And then they went out and thought they were immune to it, gallivanting about, and then got it for real because they didn't need to wear a mask. So why would they?
Right.
Didn't need to wash my hands all the time. I've already had it. So the mayor of Las Vegas thinks she got it, no test, thinks she got it, and is now immune to it with absolutely no evidence.
Right.
Either way, like it's insane.
So the word I was looking for was sensitivity. So the two factors are specificity and sensitivity, and and those are important aspects of the tests. Additionally, Enfada in the chat room is talking about the release of the antibody tests without full FDA approval. It is previously unheard of, but the reason that the FDA went ahead with what's called the Emergency Use Act or emergency use agreements, EUAs, is because these companies said they had rigorous internal standards and we needed to get tests out. And so it was part of the process. However, now the FDA is finding that a lot of these companies that said their tests were great, they really didn't have the kind of rigorous controls and standards that we had hoped for. One of the concerns with these inaccurate antibody tests is if people are using them to determine whether or not they have been infected, then, and there are lots of false positives, or false negatives, people are going to think, false positives are going to think that they're protected when they're really not. And if there's a high proportion of these faulty tests doing that, we really can't be using these antibody tests, these serological tests at an individual diagnosis level. So we need to make sure that they're accurate. From what I've read, the tests they're at a level where they are appropriate for using at a population level. So if you're looking at hundreds of thousands of people, that the level of false positive or false negative, your error bars essentially, it's acceptable enough to get a general idea of what is happening in the population at large, but they should not be used for individuals for the most part at this point in time. There are only a few that should be.
I had the exact opposite take, which is weird. The sort of take I got was like if you were showing the severe symptoms and they gave you the test, it was going to be reliable enough.
Okay,
but
so it's no.
To use it on a broad population.
No. So the difference is the PCR test that looks for viral DNA versus antibodies, which is looking for an immune response in our bodies.
Yes.
And the serology is the one that it's been slow to come, and these antibody tests we're definitely still working on it. There are a few companies that are making good ones, but not a lot of them. But there's a lot of them out there. But we have gotten to the point now. Yes, if you get one of the nasal swabs that does a PCR test to look for viral DNA, then that's going to say, yes, you have it or you don't have it. But it's not going to tell you whether you had it.
No.
Right.
The
so I think
that.
Kiki, you just said something that's really key that I'm not hearing elsewhere. And I think this is completely changing the way I'm thinking about these antibody tests, because I've thought the whole thing is kind of dumb at this point because they don't seem to be very effective and they're emboldening people, and that concerns me. But if you look at it, if you can test everybody in a county and decide that the percentage is a good one to start changing your regulations for shelter in place, that is the difference, is making a population-based decision, because then your false positives don't matter as much because it's a percentage of total population. It's not a person that you're going to say, go do what you want and they can have an exponential impact on the general population.
So here's the warning, though. Here's why I'm arguing against that. Because the only number I've heard thus far on one of these tests was a 10% false positive, which means if you take that county that has 0.5% of the population with COVID and you test all of them, you have you now have 10% of the population showing that they have it in this test.
Right. So it depends. Definitely depends. It definitely depends on which test you use.
Can't use it for
that's why the
people.
FDA. That's why the FDA is turning things around and is trying to get more regulation behind these tests and to remove some of the. To remove
the
some
FDA can regulate what they want.
Tests that are out there.
We just need to buy the test from Singapore because apparently those ones work. But
there's one
my
from
point
China,
though is
one from Germany. Yeah.
My point though is that the problem with applying anything, even if it's just got like a 1% false positive, then you got to say, what's the actual persistence of this thing in actual society? If it's actually like 0.5% or a 1%, then your chances of actually catching anybody with this disease is really small because you're creating a huge number of false positives who didn't even have a symptom, didn't have any reason to be tested, any reason to be considered. I mean,
but if you can predict how much it's going to be, and maybe you have two tests that you use to test against each other in the population, then perhaps that is something that can, but it's maybe you can combine them. And as long as you know what the rate of false positives, false negatives, the specificity, the sensitivity is, then it can be calculated and predicted, and you can check the numbers. But there's a lot to be done, and that's not being done. Potentially, one of the new tests that is coming out is a CRISPR test. There is a new diagnostic chip, which is a basically a microfluidics chip that can run thousands of tests simultaneously that uses CRISPR. They have named it Carmen, Combinatorial Arrayed Reactions for Multiplexed Evaluation of Nucleic Acids. Isn't that fancy? Carmen uses CRISPR to be able to increase its specificity because CRISPR is very specific to its targets. So using the Cas9 CRISPR system in combination with their microarray, the researchers who just published this in Nature suggest that it can be used on a number of different viruses. They tested it on a lot of different viruses, and it was under development when the whole COVID-19 thing came up, and they rushed to add SARS-CoV-2 to their analysis. And with this chip, it's a rubber chip. It's a little bit bigger than a smartphone, according to the reports, and it has tens of thousands of microwells, little tiny compartments that can hold little tiny droplets, nanoliter sized droplets. It's so tiny, smaller than a human hair. And that contains the viral genetic material from the sample. They can do about 1,000 samples at once. So you could take 1,000 different people's samples and test them all.
Is this Oxford Nanopore?
It is not Oxford Nanopore. This is a new system that has been, it's very similar, but it's under development by this group out of MIT and a couple of other, and the Broad Institute and Harvard. So MIT and Harvard. And
Harvard
that's pretty
just
much
kicked in some of the financing to MIT.
Probably. Yeah. But the platform, they say it's easily manufactured. It is easy to use in their lab. They've been able to do several, like up to 4 to 5 different runs of these microwell chips per day, which means that they could, in one lab, do upwards of 4,000 tests in a day. And so the issue is going to be cost of the analysis machinery, cost of the actual manufacture of these chips. Hopefully they are as inexpensive as they say. But the potential of being able to test lots and lots and lots of samples at the same time for something like COVID gives the opportunity of really pushing forward the effectiveness of our testing at that population level. So that's what I have for the COVID news. If you have questions about COVID, let me know. Send me an email, Kirsten@thisweekinscience.com. I'll see what I can do to check things out and look at the information that's out there to talk about it on the show. I'd love to be able to clear up any uncertainties that are out there, if at all possible. Justin, let's talk about some other science. You want to talk about viruses? Because we're talking about viruses, let's keep it going.
Singapore MIT Alliance for Research and Technology has discovered a new anti-phage defense mechanism found in some bacteria, which uses previously unknown features within their DNA to protect their DNA. So the phages, are viruses, which attack bacteria. They work by injecting their own DNA into the bacteria, where then it replicates using the bacteria's machinery for replication to the point where it destroys the bacteria. Not too unlike what the COVID-19 does to human tissue cell. In this paper, the research team describes a brand new defense system found in the bacteria that works in a unique way to protect themselves against the virus. This is led by Professor Lianrong Wang at Wuhan University. The paper was jointly written by a group of the SMARTS, Antimicrobial Resistance Interdisciplinary Research Group. So this is a group in looking at viruses to assist in tackling bacteria, who, by the way, there are antibiotic-resistant bacteria. Bacteria haven't given up. They're also trying to kill us. We're apparently not very popular on the planet. So what they've been looking at is bacterial phages, or viruses that kill bacteria, and seeing how some bacteria seem to resist the effects of those viruses. What they discovered here was that this is really novel, too. I have not heard about this. This is a very novel bacteria. What the team discovered, this is quotey voice, of Professor Peter C. Didon, who's co-author of the paper from Smart side. We previously discovered a new type of defense mechanism that bacteria use against phages, where sulfur is inserted into the DNA backbone as a phosphorothioate modification on each strand of the DNA. If the attacking phage DNA didn't have the modifications, meaning the virus DNA goes in and it's trying to replicate, but if it doesn't have this sulfur insert on it, the host enzymes chop the DNA into pieces, destroying it immediately. No virus gets populated. This restriction modification mechanism is like a bacterial immune system to protect it against invaders. What the team discovered now is an entirely new and different mechanism in which these phosphorothioates, or no L in there, thioates are located on only one strand of DNA at very high frequency. Host defense enzyme then nick one strand of the invader DNA to stop the virus from making copies of itself. This is an antibacterial story where we're using viruses as our friends to attack bacteria that are trying to kill us. But one of the things that's sort of interesting that I keep kind of thinking, if we ourselves, if the human body is incapable of producing an immune response that protects us or gives us immunity, we will at some point have to look for an ally. And maybe it's something like creating a hybrid of a bacteria that's already in our lungs, a bacteria that's already in our skin that can facilitate something like this, like a hybrid bacteria. It's an escalation, it's an arms race, it's scary, but we might have to genetically engineer, if not future humans, to be resistant to COVID-19. If it turns out, and I hope it doesn't, that we are not cannot gain immunity or vaccine, or take something wild like a hybrid bacteria that we now. I mean, we talk about a probiotic. Lather up with your anti-COVID bacteria Make sure you get it in the face mites because they love it too. You know?
Everyone loves it.
we have to start thinking about this, perhaps at some point in different ways. Anyway, I thought this was a very fascinating story. This is a way in which bacteria can fight off viruses that we didn't know existed. And it comes down to a sort of a self-genetic modification, evolutionarily speaking, of a bacteria to have this sort of unique DNA feature that trips up the viral invaders, doesn't allow them to replicate.
Yeah, I mean, they're talking about their own, it's their own phages that it trips up, right? So these bacterial viruses, but I just wonder if it would work against, our bigger viruses, or if it would take, that similar technique, do we have to CRISPR ourselves to have our cells have the little mutation, the little adaptation to trip up the viruses?
The one thing we would need to tackle, we would have to create a bacteria that had some sort of a receptor that looked like a human lung cell. For instance,
like an ACE2 for COVID. It would have to have the ACE2 receptor. Yeah.
Right. We'd have an ACE2 receptor that we could aerosolize. Like you'd walk into any department store and there'd be this aerosolized ACE2 receptor bacteria that could dismantle COVID upon contact.
That would be great. And oddly, we'd be encouraged to go to public gatherings to get enough.
And oddly, the only side effect is it turns everybody's hair completely white.
That's fine.
That's okay. I would deal with that.
That would be totally fine.
But then everybody's dyeing their hair all the time. It'd be a fabulous future. But
white hair is a good base for hair dyeing.
Yeah, that's true. Just everybody will show up a week later with neon colored hair.
COVID hairdo.
Yeah.
But yeah,
would this be permanent, Justin, the white hair? Would that be for the rest of your life? Or?
But my point, though, is that there might need to be complete rethinking in the way if all of our traditional methods are ineffective and this isn't going to go away, we might have to start thinking out of the box and how we tackle it. And we might have to start learning from do the thing that we usually do. Eventually, after wringing our hands and beating our heads against the wall, find that nature somewhere already has a solution.
That's really
and that we can just off the shelf it and play it somewhere else. And we're genius.
Sometimes we think we need to make things ourselves, but really we just need to find what's already been solved by Mother Nature. Right?
What if we weaponize those face mites? That's what I'm wondering.
I'm just gonna leave that one there. We're gonna let that one simmer for a minute. And I'm gonna move on for a moment. I'm gonna let everyone know that this is This Week in Science. And if you are interested in a TWIS shirt or mug or other item of TWIS merchandise, some good TWIS stuff, head over to twis.org, click on our Zazzle link, and browse our store. It will help to support the show. Is it time for that other part of the show that we love? Blair's Animal Corner?
Oh, I thought it was the other part of the show. Oh.
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
Oh man, I just have some cute, feel-good animal stories today. No more killer viruses or murder hornets. Yeah, I just have some fun stories for the Animal Corner, keeping it nice and light, like a nice whipped cream. Tonight we have a story from Edith Cowan University in Australia. Listening to dolphin chatter. Dolphins, they make fun sounds. They whistle, they cheer. There you go. And so it turns out that a new piece of research from Australia is looking at the unique attributes to whistles of individual bottlenose dolphins. They studied in particular Western Australia's Swan River and the dolphins that live there. From April to September 2013, they systematically monitored an area within the eastern part of the harbor where the river narrows. So it's kind of a choke point. So it allows them to record a lot of information from these dolphins. They made acoustic recordings throughout all observation times with handheld hydrophones. They had them over the side of a small craft. They lowered them to 1.5 meters deep. And they matched over 500 unique whistles with dolphin photos over the period of the study. So basically, they would take a snapshot every time they recorded sounds and could kind of face match who's in this photo and what sounds are we hearing, and who's in this photo and what sounds are we hearing, and what faces and sounds are in common. So they could start to try to assign particular whistles to particular dolphins. So basically, they're figuring out their voices. So the hope is that this could be extrapolated on a much larger scale to be able to track dolphins. And that's because normally when we track dolphins, it's only during the day and it's through photographing. And it's by looking at nicks and notches in dorsal fins when they come to the surface. So it's not underwater, it's above water, and it's just looking at their dorsal fin. So it's pretty hard to be specific and exact about which dolphin you're looking at, especially if it's a younger dolphin or a dolphin that doesn't have a lot of scarring yet on their dorsal fin. So if they can instead just go, oh, that sounds like Jerry. Like, it's just, you could have identified dolphins. You could, just by sounds, you could have hydrophones that are constantly there. So you wouldn't have to wait for it to be light out to be able to take pictures. And you could track those sounds across the ocean.
That sounds awesome.
Yeah. So even just with this very short-term study, April to September of 1 year with 500 calls, they were able to narrow it down to a very narrow range of possible dolphins from each sound that they heard. So they had a pretty good idea of who was who, just based on this short-term study. So definitely they think that this could be expanded so that we could potentially track these animals just by their voice.
I have a hard time believing that this is the first time that we've done this.
Yeah,
like
so...
we know that they've been talking for so long and we've been trying to figure out what their chatter is all about, right? Oh, are they saying something? Like, wouldn't you think that they've got these social groups, they've got to recognize each other and identify each other and their voices travel through the water. So, hi, people, like, isn't there nobody... What?
I don't know. I mean, this is the first time that I've seen this. And as far as we know, as far as the researchers know, this was the first instance of this. But I think, we've done a lot of studies, or we've reported on a lot of studies about people assigning names to dolphins. You know, the idea that there's a particular call that other dolphins use when they see that particular dolphin. We've recognized that there's very specific cliques of dolphins that like to hang out with one another. So I think we've kind of skirted around this topic, but I guess it hasn't been zeroed in on yet.
Right.
And I wonder if it is because it's so hard, considering they do run in cliques, that it's probably really difficult to get it narrowed down to an individual.
I think the earliest research into dolphins that was really looking at language, that was really trying to analyze language, happened at a particular time, and the head researcher also segued into LSD and dolphins.
What? Oh,
yeah.
Wow.
And I think not really. I think first of all, I would love to have seen where that research went, but also I think it set back research on dolphins by some decades of people distancing themselves from.
Yeah, it's very interesting to see that particular dolphins would sound very particular, but somebody in the chat room is mentioning, I wonder why humans look so different from each other, but animals look very similar. Right. That's to us. To those animals, they look very different. And in fact, I think that we all sound very different from one another. You could probably hear, for example, your favorite podcast playing without any other sound cues and recognize that person's voice. And it might sound like all dog barks sound pretty similar, especially within a breed. But to dogs, they sound very different. So I think it's all about...
a dog owner. I think a dog owner is going to pick their dog's bark out of a crowd.
Yeah. So it's all about familiarity. It's not just about being within the species. But if you spend all day looking at dolphins, you're going to start to recognize dolphins. I talk all the time about how when I was a primate keeper, I had to take care of a group of squirrel monkeys that were 18. And on day 1, they all looked exactly the same. And by the end of my training on day 5, I had to be able to tell them all just by the way that they looked. And I got there. It was tough. I had to make flashcards. I had to figure it out. But then by the time I was working in that space, it was, oh, you're Che, you're Mac. Like, I know exactly who everyone was because you start to recognize its familiarity. And so I think that's true with faces. It's true with voices. It's true with dolphin dorsal fins, and it's true with dolphin whistles. So,
yep.
There you go.
Fantastic.
Mm-hmm.
Let's track those dolphins. What's next?
Speaking of tracking animals, salmon, another animal living in the deep blue, that is very good at tracking themselves. They are amazing at being able to start in fresh water, leave that space where they were hatched, go out into the open ocean, spend a long time out there, and somehow find their way back to where they were born. So how do you find the entrance to that river system, and how do you find your way up that river to your nesting site? This is from Oregon State University, and this is looking specifically at magnetite and how magnetic fields might have something to do with it. So we know that there is a chemical component with the way that salmon find their way back home. There is a chemical nature of the water in their natal grounds, so that
like an odor.
Right. So that they can find exactly where they came from. We know that scent and memory are really closely linked, and whether or not we could pick out that's the smell of my nursery, just, from it, it might create some sort of emotional or memory response if we could smell a baby blanket from our childhood or something like that. So that makes sense, right? That there's chemical cues involved when you're going up those rivers trying to find the right branch to get to where you came from. But the kind of second question of that is, how the heck do they get from the open ocean to the river system to begin with? In the case of some salmon, if they're halfway across the Pacific towards Japan, and then it's time for them to come back, how can they navigate
around
the entire ocean to get back to where they came from? So this is a pretty interesting study where they took juvenile Chinook salmon and they exposed them to a brief but strong magnetic pulse that is known to reverse the polarity of magnetic particles and affect magnetic orientation behavior in other animals. So they did this magnetic pulse to these juvenile salmon, and then they compared the behavior of pulsed and unpulsed fish, and they compared it in a magnetic coil system under a pair of conditions: the local magnetic field and one where they made a map-like information grid from the magnetic field that was shifted. So one was just like general magnetic fields around, and one that kind of tried to mimic what it would be like in the ocean, and then they used the pulse to change what it looked like. So in the local field, they behaved pretty much the same, but when they used this magnetic map and they shifted it, the test and control salmon behaved totally different. The control fish were randomly oriented, and the pulse fish tried to go somewhere very specifically. So that suggests that this magnetite, which would have been altered by the pulse that's in their body, may play a role in navigation of salmon.
But the implications of that, then, are that there's a powerful enough magnetic signature that you could follow across an ocean to
everywhere.
Get to a specific...
Right, birds use it.
Yeah, but
sea turtles
everywhere.
use it.
If half of migratory animals showed up at the North Pole, or the true North, or the other North, what magnetic North, fine, I get it. But they show up to the XYZ River in Klamath Falls, like, or whatever. Like they find this like
right.
very.
So say you come from around the Columbia River, Portland, Oregon. You're a salmon that's made your way down from the mountain streams. You're in the Columbia River. You end up out in the Pacific Ocean. You swim across like Blair said, to Japan. As you're doing all this, you are oriented to the North Pole where let's see, if I'm heading that direction, it's going to be on my right side. The North Pole is kind of going to be to my right. And so my brain will get used to that. And then at a certain point, my biochemistry says, time to go have babies. And so I got to figure out what to do. And so, how do I get back home? Oh, well, I came this way and it was on my right. Maybe I just got to turn and have it be on my left. Now I'm going to head back. And you end up at least somewhere near the coastline of the United States. And at that point, chemical signatures start drawing you in to where you were born and where you came from. And that's the interesting part about where the mix between that broader homing instinct and the more specific.
Yeah, so I think also remember that there are animals that can sense electric fields. So your heart makes an electric field that little fish under the sand, like little halibut, shark can detect their heart beating because of the electric field created by their heart. And that same structure can also detect electromagnetic fields coming from the earth to help navigate. So I think there's a lot that's the earth is a lot of information that the earth is sending us that we don't always realize. And
the whole thing is making me, no, I don't understand how I still it's just so incredible to me.
So it is incredible.
If you were telling me this, I wouldn't believe you.
But Justin, we've talked about this before with relation to pigeons.
No. Yeah.
We've talked about the magnetic particles with relation to sea turtles. And why now with salmon?
Real. I'm not actually denying that it exists. But if you were to describe to me that there's a fish that could travel halfway, there's nothing I can grab onto that makes sense. Even now, even knowing that it's true. And I fished for salmon. No, I fish for salmon in the rivers and the ocean. I'm not actually skeptical that salmon spawn. Just to make that clear, in case anybody out there is worried that Justin doesn't believe that salmon spawn. Not what I'm saying. If you were to tell me that without me knowing that, I wouldn't believe you.
Salmon are amazing. There are many species of animals.
Incredible.
Cool.
It's an amazing thing. Awe-inspiring.
Can't explain things you've heard before.
And now, I want to say thank you for listening to TWIS. You are the reason that we are able to do what we do every week, bring you up to date and down to earth views on science discoveries. Yes. With your help, we can do even more. Together, we can really bring a sane perspective to a world full of misinformation. Head over to twis.org right now, click on the Patreon link, and choose your level of support. Be a part of bringing sanity and science to more people with TWIS.
We can't explain things you've heard before.
And we're back. You're listening to This Week in Science.
All right. You know what we've got right now?
Do we have What Has Science Done For Me lately?
That's right. It's time for This Week in What Has Science Done For Me lately. Our writer today says, Dear Kirsten, Justin, and Blair, what has science done for me lately? Well, by lately, I mean most of my life. Starting at about age 11, this was in 1957, I discovered science and was hooked. I remember lying in my bed at night as a boy, earpiece in my ear as I listened to my crystal radio. How I marveled that this little coil and crystal with no battery, no power could bring me voices from all over the world. Over the years, my parents were victims of a merciless barrage of requests for science-y things. A chemistry set, geology set, rock collecting expeditions, microscope set, ham radio telescope, space for a laboratory at home. It only stopped when I moved out. I think the last straw was when I built a nuclear reactor in the backyard, and my dad had to check to when he got home from work so the neighborhood wouldn't blow up. Wait, what? They did their best to keep up, and with their encouragement, I eventually went to college. I was torn between astronomy and engineering, but eventually chose the one with the greater employment potential. However, I've always kept astronomy as my favorite interest. My wife can attest to the time and money that has been invested. Science has given me a logical foundation for discovering the world. It has given me hobbies, passions, and a career. It has given me a profound sense of awe at the universe we live in. It has kept me up until 2 a.m. to observe the stars or watch Voyager sail by Saturn. It has given me things to say when people ask me, so what, about our investments in science. It has allowed me to follow fields such as astrophysics, mathematics, and quantum mechanics in a way that helps me deeply appreciate the complexities of the world. Science has also added many happy and productive years to my life by helping me battle cancer, as I mentioned in a letter a while back. But perhaps more importantly, it has brought me great joy in so many ways. And lately, it has brought me to TWIS. Science brings just as much excitement now at age 73 as it did when I was 11. Few things in life can do that. Thank you for your engaging show. I can't wait to hear the next episode. Yours truly, Selden McCabe. Thank you, Selden. Thank you so much for writing in and letting us know your appreciation of science. It sounds like science has done much for you over the years. I love that. And I hope there are many other people out there for whom science is a joy in your life and that it adds to what enjoyment you have of things in the world. And if you want to write me a letter, send a "What has science done for me lately?" sonnet, haiku, song, just a letter to Kirsten, KIRSTEN, at thisweekinscience.com. All right.
All right. I think it's time for more science.
It is time for a little bit more science. You want to hear about the black hole in our neighborhood?
Yes. Hopefully it will not destroy us all.
It's not going to.
Okay.
And by neighborhood, I mean 1,000 light years away.
Oh,
so
yeah. Hey, black hole. See you never. Bye.
It's over there. Yeah, it's over there. See you never. Now, scientists for a long time have been hypothesizing that there are many of these dark spots in our universe where there are black holes that aren't so big that they cause chaos and release lots of energy into their nearby environment. Now, when we think of black holes, we often think of quasars because the black hole has such a pull, gravitational pull, that lots of material is falling into them and creating these massive jets that we can see through, through our electromagnetic spectrum, radio telemetry, through space. But now, using the European Southern Observatory in Australia, not Australia, I'm sorry, I'm putting things all wrong. European Southern Observatory in Chile, this 2.2 meter telescope in Chile has discovered this little tiny not party animal, about 1,000 light years away from us. And in the looking for it, they didn't find, like I said, big jets of energetic release. What they saw were two stars orbiting nothing at all. And so what they've done now is set up this new system of looking for binary star systems and tracking the movements of these binary or trinary star systems to see what the stars are traveling around. Are the stars orbiting each other, or are they orbiting something else that we can't see? Aha.
We're one step closer to one of my predictions.
Yeah.
Which was we would find a solar system basically of black holes. With black holes going around black holes. Like, why not?
We haven't gone that far out. Yeah,
it's just gravity.
We just need to keep looking, right?
Yeah.
Yes. And so this black hole...
quasars are the anchors for galaxies. They're the thing that when in the center of the spinning galaxies, that's what's in the middle, keeping the whole thing gravitationally linked.
A galaxy, right. So like the Milky Way galaxy that we're a part of has a massive, supermassive black hole at the center. There are quasar jets that come out of them. Yes. But this is a little one that doesn't really make a peep at all. It's just dark. And it's dark and quiet. And the only way we found it is by looking at the orbits of stars. And it seems, based on our calculations, that this black hole is a little one. It's only about 4 times the mass of our sun. So it's not a giant black hole. It's stellar mass black hole. This is a small black hole.
Yeah, that's I actually for some reason thought you needed way more than our sun. I think more than 4 times our sun to be a black hole. That's amazing. I think that's a sustainable one, presumably being technical.
Yeah, the researchers say that at least 4 times the mass of the sun an invisible object, especially that seems to have a mass of about 4 times that of the sun, can only be a black hole. These are the conclusions of some of the researchers at the European Southern Observatory.
Or something we haven't discovered yet.
Yeah. This black hole also, although it's more massive than our sun, is very small. So it only has a footprint of like 7.5 kilometers across. So it's because it's a black hole, it's dense and small. And it's hidden in a system called HR 6819. And
toddler black hole. There you go.
It's a baby toddler black hole. Yeah, and it's in the middle. It's in a southern constellation called Telescopium. I have never heard of this constellation, maybe because I am biased to the northern hemisphere, but I find it an interesting constellation. Telescopium. And excuse me, not 7.5 kilometers, 7.5 miles wide, about 12 kilometers wide. Still very small. And it's just a nice little thing, which indicates that there are probably lots and lots and lots of these little tiny, quiet black holes in our universe. And there may even be little tiny black holes much closer to us than this 1,000 light years away. And that is what the researchers are speculating on, is that these lurkers are out there, maybe even within a couple of dozen light years of Earth.
So I just want to throw out there, I know we just made the appeal for what has science done for me lately for poems and things. We just said a lot of descriptive words in relation to a black hole that is begging for a black hole cartoon. That a lurker, a toddler, doesn't make a peep. I just say, this sounds like this is rich with material.
It is rich with material. And I think one of the other really great things about this is that if you are in the southern hemisphere, this is a star system that you can see with the naked eye. You don't even need binoculars or a telescope.
You don't need a telescope to see telescopium?
Nope, you don't.
That's funny.
You do not.
I would have assumed.
I know, right? Telescopium. You need a telescope to see. How do you see it? With a telescopium.
I totally assumed.
Yes. No, you can see it with your naked eyes at night, clear skies. If it's in the sky, you too can see where a black hole is in our visible spectrum, which is pretty neat, I think. Because for the most part, we just say, we can't see a black hole. I can't see a black hole. You can't see a black hole, but we can get as close to it as possible. Speaking of otherworldly things, another study, there's a bunch out of MIT this week, apparently. Another bit of news, researchers in the researcher, what's her name? Sarah Seeger she is the class of 1941 professor of planetary science, physics, and aeronautics and astronautics at MIT. she's looking for life on other planets. Well, she's looking to figure out how life could be on other planets and has published a paper in Nature Astronomy about her and her colleagues' ideas of life on planets with hydrogen atmospheres. She has done a bunch of studies in the laboratory simulating hydrogen atmospheres with microbes, Earth microbes, very simple microbes like E. coli and yeast, to be able to determine whether or not they can live in hydrogen atmospheres. We know that once upon a time, oxygen did not dominate our atmosphere, and there was a long period of time in which nitrogen and hydrogen were much more dominant in the atmospheric conditions before oxygen came to fore.
Even the ocean is a largely hydrogen-rich environment.
Yeah, and the ocean is hydrogen-rich, exactly. And so we know that there are extremophiles who can exist in hydrogenic conditions here on the planet. But the idea is that she is arguing, because of the work that they've done, they weren't looking to see whether life could evolve in a hydrogen atmosphere condition. They were just looking to see if life could thrive. If you stuck microbes in it, could they live? And they
From
did.
this planet, slap them in there. Wow.
And so based on that work, they're arguing that we really should be looking at other at planets that have hydrogen-rich atmospheres. That oxygen is not necessarily the thing that we should always be looking for. I mean, if you think about it, hydrogen, it could be in water on a planet. It could also be in methane, right? There's hydrogen peroxide. There's hydrogen gas. There's, hydrogen is a very, it's not noxious necessarily. Yeah. It's not a bad, it's not like oxygen actually is, it's
It was the first mass death extinction event on the planet when it became oxygenated. Right. But it's the important thing to remember is our planet, life started on our planet pre-oxygen atmosphere.
Yeah.
So it almost is illogical to take the leap to only look at oxygen-rich planets because that's not how it got started here. That wasn't the base point for planet Earth life.
Yeah, I've mentioned recently, stuck inside, I've been watching a lot of Star Trek, and I always think it's so funny how they pretty much only mess around with Class M planets, which have oxygen. They never go to planets, it seems like, where they have to be wearing spacesuits.
Makes it much easier.
Right, it makes it easier to film. I get that.
It's also because it started as a 60s TV show, so they also had, it's hominins everywhere. So, yeah, there's a lot of things.
But of course, there's this part of me that's like, but why are you assuming? Like, all these planets that aren't Class M planets, they've got to, if there's life on all these Class M planets, there's got to be life on these other planets. Why are you assuming that they all need oxygen?
Because nobody wanted to shoot an episode where everybody's wearing, like, an astronaut suit.
Yeah.
Floating around in half zero.
Not compelling TV. But no, it is kind of related to similar thinking, where we assume that the place where our life bloomed and is currently thriving, if you want to call it that, then it has to be like that for other life to thrive.
It does not have to be that way for life to thrive, and it depends on what thriving is.
Right.
That's what you want to call that.
Yes, whatever.
And as Robert Bigelow in the chat room says, oxygen is a catalyst, and hydrogen is the smallest element on the periodic table. Yeah.
Going to be there.
Yeah. So why not expand our view of where life can be? Justin, expand our view some more with more science.
Expand our view of where we can charge an electric car. Okay. With a study that is a little bit like the one I'm going to talk about. Robust and efficient wireless power transfer using a switch mode implementation of a nonlinear parity times metric circuit was the title of the study. And so I thought, oh no, this means my cell phone's going to get even smaller. It's going to not even be able to produce a font that's legible to me. But this study has nothing to do with that. This is engineers at Stanford that have made a truly functional innovation that could allow, I said that as if Stanford never comes up with truly functional innovations. But no, this is a truly functional innovation in a field that we've talked about a lot, which is charging electric cars on highways. there's been a lot of talk, a lot of throwing ideas out there, but there hasn't been anything actually innovated that could scale to do it. But that's exactly what this looks like. So this, which if you can have cars that are getting charged by the road, that means you get rid of any sort of range issue with an electric car. And for those that don't have this big a problem with range, you lighten them considerably, making them much more efficient if the roadway can actually charge them as they go. So 3 years ago, this Stanford electrical engineer, Shan-Hui Fan, and Sid Asawawarerit, a graduate student in his lab, built the first system that could wirelessly recharge objects in motion. Other than that being really cool, it sucked. The system transmitted about 10% of the power flowing through it, which if you're trying to power an electric car battery, only being able to utilize 10% is tremendously inefficient. It's basically a massive waste of time. You'd be better off putting just coal in the thing and burning it at that point to make it run. But now, obviously, it was 3 years ago. Now they have published in Nature Electronics, and the two engineers are demonstrating their latest version there. They have gotten the system's wireless transmission efficiency to 92%, which your power plant power line to house loses like 50%. So depending on how close, you still have the wire issue, it's still there, but depending on how close the power source is, 92 efficiency is insanely high. That is tremendous. And this isn't a wireless technology that is charging something that is in motion. Technology can not only be scaled up to power a car moving down the road, that's going to take some time. In the near term, system could make a practical wireless technology that could recharge robots, say, in a warehouse. So you could have a central wireless power system built into the factory floor. Robots are running around. They don't need to do the Roomba thing where they pull into the charger once in a while. They can just keep going 24/7. This is quotey voice of Fan, who's the professor in this. This is a significant step toward a practical and efficient system for wireless recharging automobiles and robots, even when they're moving at high speeds. We'd have to scale the power up to recharge a moving car, but I don't think that's a serious roadblock. For recharging robots, we're already within the range of practical readiness. So wireless chargers emit electricity by creating magnetic fields that oscillate at a frequency that creates a resonating vibration and magnetic coils on the receiving end. Problem is, resonant frequency changes if the distance between the source and the receiver changes even by a very, very small amount. That's why if you have a wireless phone charger, you can't charge your phone while you're using it. You have to set it down on the charger, which just avoids the step actually of plugging in a cord, but it has to sit there as if it was plugged in. There's kind of no difference. Basically the same. The key, Asawa Wara explained, was that to replace the original amplifier with a far more efficient switch mode amplifier. Such amplifiers, it's not something that they invented. They only produce high efficiency amplification, though, under extremely precise conditions, and that wasn't available. So it took 3 years of tinkering, theoretical thinkering, to design a circuit configuration that might work. And when they tested it, it worked. So yeah, right now they can transmit 10 watts of electricity over a distance of 2 to 3 feet. Not a big deal. They say they can scale this up to a point where it could handle a vehicle moving 70 miles an hour across it and still do charging. Only limiting factor right now, they're saying it would be how fast the battery could actually absorb power as it crosses over their chargers. So then more and more charges. So there's also humans. Humans were burning cell phone towers because they thought they were emitting COVID?
Yeah,
like
5G.
There was a whole campaign against the wireless meters that could be read. Like there's so much.
So I have an idea. I think I can fix this.
Human.
You take the car, you make the wheels metal, you put them on a track, you create
a train.
Yeah, exactly.
A train.
So you have these different cars that are connected because they're all going to the same place. Then you create switches so that they can turn to have different routes. So I think we fixed it.
I think Japan already has these, like, very well designed
electric trains. So, but we're not going to do mass transit anymore because of COVID. We all need to be in our separate cars. But this is Sid Sabawarit, who is saying the wireless chargers shouldn't pose any sort of a health risk. Even the ones that they would scale up to that could power cars produce magnetic fields that are already within established existing safety guidelines. So, and magnetic fields already transmit electricity through humans without them feeling a thing. Although I guess if you're a salmon, you might notice. May have salmon showing up on the 80 or 5 or the 405, trying to get their way back home.
Something to consider.
Something to consider.
So one of the obstacles is, of course, getting these embedded into highways. This is a long-term sort of ways off thing, even if the technology exists today. However, one of the interesting things that they point out, or a fan is saying he can imagine drones. So you could embed these on rooftops, maybe towers, that sort of thing. So if you had drones that could maybe not small enough that they wouldn't hold a charge long enough to go a great distance, but if they have charging points along the way that they pass through, they could remain charged on their journey and keep flying. And that sort of then opens up that vision that we got of drones delivering Amazon packages to backyards, or the pizza delivery that comes down and drops on your front porch. I mean, talk about touchless delivery. Mm-hmm. If you had a highway of rooftops and towers that these things can just pass by, recharge, they could stay in the air as long as that network is in place.
I'm imagining hoops that are kind of like the goals in Quidditch in Harry Potter. They have to fly through the hoops. But for the electric road kind of idea, Ed in the chat room is bringing up there's one in Scandinavia somewhere. There's also an electric road in San Diego, and I think there's another one in Texas somewhere. But I mean, these electric road ideas aren't new, but they've been, I mean, maybe it's the technology is too hard to implement, too expensive for the actual application and implementation. And so we have not seen anything work well enough to make it adoptable. We've tried things out, it just hasn't worked.
Yeah, but that's why the new version of it, it's sort of saying like, well, we tried an electronic handheld device, but the Palm Pilot just sucked. So we all gave up.
We're done.
Right? Like, no, that's just the first step. But at 92% efficiency, with what they're saying is, I think it was a 4-foot range. So you would need multiples trickling in as the vehicle drove. But you could, yes, absolutely. You could absolutely see this as that next step to make that seemingly impossible much closer to reality, much closer to something that those other systems can incorporate and work with.
It seems to me like it would make sense to pilot this as wireless charging parking lots.
Right.
No.
Or metered parking that's wireless charging.
At that point, you can just plug in.
But you can't. There aren't plugs everywhere. So this is something that would you could make a huge. I mean, what's the one of the main stoppers to transitioning en masse to electric cars? It's the infrastructure.
It's the infrastructure.
So if that would be a way, that would be a stepping point in between here and the electric road, where you could make electric cars way more applicable to everyday life. Sure, your road trips still might not be taken care of. Truckers still need a way to transport goods, but for just the commuter, if you're charging just by being parked, even while you're at the grocery store,
no parking
as a function of that, then that can be a huge way to increase kind of testing on this and ways that it would work, but also its impact on the environment. But I do
roads
think
by themselves are the worst.
Before you have a fully electric road, you might want to just increase how many people out there have electric cars. I don't know. I feel like I'm surprised we haven't done wireless parking charging yet. That's all I'm saying. Is I'm surprised we haven't gotten there yet.
Money. Adoption. Just social effort. Yeah, there's been no flatten the curve for electric vehicles yet. So yeah. As Jeremy in the chat room is saying, if you can put in wiring for charging, you can put in a plug. So if you're not able to put in a plug, you're probably not able to put in the wiring for the charging either. So, I mean, there are a lot of things that have to fit together.
Mm-hmm. That's why the wireless chargers make me laugh on phone.
Yeah, because it's still a wire.
You've got to set it down on a thing and leave it there. It's the wire. Oh, I didn't have to do this. Oh, wow, an innovation. Wow, that's a game changer.
Yeah.
Speaking of game changers, I do love things that could potentially help us live better in our modern lives. Researchers are trying to figure out how to deal with clock shifting and effects like social jet lag or just jet lag. And as a result, researchers have recently looked at from the National Institute of Sciences in Beijing. They've published a study looking at a mushroom, or a fungus protein. And this fungus protein has the potential to knock out jet lag, or at least make it a lot better. The study was published in Science Translational Medicine this week. And what they found in their study on mice was that when the mice were given this compound called cordycepin, it helped reset their circadian rhythms so that they recovered from time shifting a heck of a lot faster than would normally happen. They haven't done the studies on humans yet, but what they discovered is that they have this synthetic molecule version of cordycepin. It can bind to an enzyme that's called RUVBL2, RUVBL2, and that influences clock genes that are influential into our circadian rhythm. And so the genes get turned on or off, and what RUVBL2 does is it's really active in the suprachiasmatic nucleus of the hypothalamus, which is where your circadian clock gets set every day. This is the light-sensitive area of our brain that tells us when we're going to get tired and when we're going to want to go to sleep and wake up in the morning. Cordycepin binds to this enzyme, causes a whole bunch of things happen, but crucial thing that happens is that a protein is made to leave chromatin, so that the DNA gets uncondensed, and there's a bunch of genes related to circadian rhythm, E-box genes, that then get transcribed. And so they're thinking that cordycepin is kind of this key to the lock that unlocks these clock genes. And the researchers theorize what they say, this magic drug can change the clock phase up to 12 hours, and a timed regulation of our internal body clock is possible. That's what they say.
Magic drug, you say?
Magic drug.
Okay, note to self. Buy 6 pounds of mushrooms.
That's right.
Hey,
so let me tell you more about. Yeah.
Are we ever going to get to use this again?
I hope so. Possibly.
Is it even possible to get jet lag right now?
Right. Right. Some, yes.
Well,
shift
for
workers
shift
are still working. Yeah.
Yeah.
Shift workers are still working.
I might end up on a graveyard shift soon. Ooh. Yeah. So where do I get this mushroom?
Right. So the story of this fungus is very interesting because the protein comes from a fungus that is Cordyceps militaris. Now, Cordyceps militaris is a version of, it's a cousin to a rare fungus that's found in the Himalayas called Cordyceps sinensis. And Cordyceps sinensis in the Himalayas is a parasitic fungus that controls caterpillars and then kills them, and then it sprouts out of their head.
Oh my
god! And people go. It's like it's like a truffle for the Chinese, and it's become a quote unquote Himalayan Viagra, and it can sell for about $35,000 a pound. It's become a major source of income for rural Tibetans who go out into the countryside searching for these caterpillars with fungal erections out of their heads on the ground, and they dig them up and then they go sell them to people. And the reason that Viagra kind of explains itself. It's been known for centuries as a compound. The fungus itself, when consumed, gives people focus, energy, and long-lasting erections. So the militaris has been used similarly for less money because it can be produced in laboratories and can be harvested very easily. You don't have to go hiking in the Himalayas and destroying the environment to be able to get it. But they have discovered that it has a whole bunch of anti-inflammatory and other also anti-cancerous potentially effects, where it leads to tumor cell apoptosis in some situations. There are some really interesting metabolic effects of the active ingredients.
Well, if it's able to reset signaling communications, then I mean that's the main driver of cancer, is just actually the lack of signaling communication that's taking place to tell it stop growing. Don't grow new vesicles. Take a pause after you've grown for a bit. Like, all that signaling stops reaching the cancer cell, and that's why it's doing this thing in the first place. So if you have something that is encouraging and resetting signaling, I can see how that would be beneficial.
Right. So it could be beneficial. I mean, there's a lot of research going on right now. Right now, this one particular study suggests it may be useful for jet lag. However, the studies have only been done on mice, yet to be looked at in humans. About shrooms. Or
how is there a mushroom that comes out of the head
caterpillar
of a
fungus?
Yeah. How does nobody have a sample and is like, yeah, now I have a giant lab full of this, or a giant I get that people are interested in making a biofuel or making a pharmaceutical that can go somewhere. If this thing sells for $35,000 or whatever it was, how does somebody not be instead of just harvesting one caterpillar at a time?
They have.
Okay.
Yeah. Starting in it's about 2014, according to the rabbit hole that I fell down. Chinese labs figured out how to start growing it in the laboratory. In about 2016, there were some pretty major groups that were growing it and selling it. And so it's become a thing. But still, in Chinese herbal medicine and culture, having the original, the natural found in the Himalayas is probably always going to be the most sought after, as opposed to something that's a little bit cheaper that comes from a lab.
Well, yeah, but it won't be because all of it will have been found in nature.
Right. Well, at one point it was.
That's all it comes down to the salesperson.
Exactly. Sales is a heck of a thing. Yeah. So anyway, these cordyceps, these shrooms, they are something else. Justin, do you have another story?
No, I have a wind down at the end of this, and then I'm going to bed. What do you guys got?
Okay. All right. Well, I was going to talk about murder hornets, but Blair brought them up at the beginning of the show, so we don't need to talk about murder hornets. I mean, all I was going to say is don't panic.
Did it make the show? I thought it was pre-show. Did we talk about it on the actual show?
We did. The murder hornets are not something that we really need to worry about. They're going to go kill bees, so we need to be worried about them for our bees. There have only been 2 dead murder hornets that have been identified in Washington. So it's not even a big thing, and it could potentially be averted. Could be something we don't have to worry about. So murder hornets, don't worry about it.
All the other sites are completely anecdotal and people saying, like, I think that's a really big bee. And that's pretty much it.
Yep.
The last time I was prepared not to worry about something, there's a virus that caused the global pandemic. So I'm going to say, watch out for the murder hornets. Watch out for them. Let's take every action.
Remember how we did a whole thing about sensationalism?
Listen to me, everybody.
Did we?
Listen to Blair. Oh. We did. So speaking of the end of the show and how we're all going to go get some rest, I wanted to talk about very quickly a study that's out this week, looking at memory and how memories get played back while we sleep. Now, this is something that we have studied in a correlational manner before because of fMRI and our ability to look at the blood flow in the brain. And we've done tests where you get people to do some kind of activity or learn something, and then as they're sleeping, you try and see if that activity is repeated again in the brain. But to date, really, like I said, it's just been correlational. But because we have people now who are getting brain implants that are part of a program for BrainGate, which is it's a brain-computer interface that's being developed. These people we have a system in which we have a way to look at people's brains. It's already been invasive. We don't have to be more invasive. And so researchers took advantage of the fact that these individuals already have brain implants, and they said, hey, do you want to do this study? And so some individuals with tetraplegia had these 96-channel silicon microelectrode arrays placed neurosurgically in their brains as part of the BrainGate 2 pilot clinical trial. And then they had them play Simon. And, you know, the game with the lights, with the
memory
light
repeat game.
Yeah, and they had them play Simon and had them use their eyes because they're tetraplegics. They're not able to actually move a mouse or do anything, but they moved a cursor using the power of their brains to follow the pattern, learn the patterns within this game, Simon. And then they had them take a nap. And they watched the electrical activity while they were awake playing Simon, and again while they were asleep and what happened in their brains. And their brains repeated the pattern while they were sleeping. So we have actual electrical recordings now that we have not had before.
I'm exactly picturing, the picture of her brain, and then it's like red, blue, yellow, green, 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 yellow, blue, green, green, yellow, green. That was, but Blair, I'm surprised you haven't signed up for this already.
Well, I did at the very beginning. I was like, oh yeah, brain implants. Oh, no thanks. Oh wait, actually.
That's actually your future.
That sounds really cool.
That sounds like your future. I mean, if you're going to be a head in a jar, you gotta be connected to the outside
just a hop,
somehow.
skip, and a jump. That's
right. Just a hop, skip, and a jump. That's right.
Pretty cool.
Yeah. So anyway, the researchers say that what they did with pre to post task rest the correlations with these repeated sequences increase more than the sequences with the correlations with control sequences. And so it's direct evidence of learning related replay in the human brain, which is kind of neat because we've always been like, yeah, our brain replays stuff. And then it's like, well, we think it does. We have this evidence around it, but this is very direct, which is really cool and a neat way to study it on top of it.
The main theory, right, is that we're going through and going like, okay, keep this. Okay, throw that away. Throw that away. Throw that away. Keep this. Okay, nope, won't need that. Won't need that. Oh, you won't need your coworker's wife's name, but you do definitely need to remember that pattern from Simon.
That's right.
So this was actually one of my favorite versions of these correlative studies. Was they had students study some material, and then they sent the two groups home. One was not allowed to drink, and one was volunteering to do some drinking that evening.
I remember this one.
And it was actually the drinkers who were able to better remember because they had no new competing memories because the alcohol sort of subdued the new memory uptake to an extent that the only thing they had to replay from earlier that day was the material they studied, whilst the other group had all this new information like the coworker's name. Don't have to remember that. I got to throw that out. The satin pattern. I remembered, I got to do this on that level of this video game. And what's this? I got some bills due. I should probably remember that. It's going to be on a Tuesday, but not this coming Tuesday, the one out. They had all this competing information. So the pattern didn't keep repeating. But the students who studied the material and went off drinking, that's all. That's the last really informationally useful anything that they encountered that day. And so it was locked in better because it was well, I guess we couldn't see or didn't know, but that was the correlative. That was sort of the assumption of what was taking place.
Yeah. Inhibitions removed also. Blair, what you got?
Oh, just koalas licking trees.
What? Why?
I assumed anyway. Like, why wouldn't? That's where they hang out. Like, who wouldn't?
This is from University of Sydney, and the prevailing theory is that koalas don't need to drink. They get all of the water that they need from the leaves that they eat. And that these cases of koalas needing to drink water after the wildfires is because of extreme dry spells and not having the access to the food and being just generally burnt. But now we have evidence that, in fact, koalas are, in fact, drinking water by licking trees that they're perched on when it's raining. They got 44 observations between 2006 and 2019. So let's back up and hear that again. In 13 years, they had 44 observations.
Wow.
That's not a whole lot. But then they also got 2 other observations of them drinking from standing water. One was an adult female with a joey who drank for an uninterrupted 15 minutes, and the other was an adult man who drank for 34 minutes straight. So it seems like koalas do, in fact, supplement their water intake that they mostly get from leaves with water when there is rain. So that does mean that if there's a drought or anything else that could impact water availability for koalas, that could potentially be a problem.
I'm going to have a follow-up question in the afternoon.
Okay.
Fantastic. Tree-licking koalas. Justin, you need some sleep. Let's try and let you do that, and everyone else out there. Thank you for listening. I hope you enjoyed the show. And if you did, maybe consider sharing it with a friend. Shout outs to Fada for his help with social media and show notes. Gord for manning the chat room. ID4, thank you for recording the show. And I would love to thank our Patreon sponsors and the Burroughs Welcome Fund for their generous support. Thank you to, see if I can get in here, Paul Disney, Andrew Swanson, Stu Pollock, Ed Dyer, Ken Hayes, Craig Landon, Tony Steele, Alex Wilson, Steve DeBell, Joshua Fury, Philip Shane, Ed Loves Science, Mark Mazzaros, Richard Porter, Sky Luke, Brian Condren, Richard, Eric Knapp, Bill K, Jason Roberts, Matthew Litwin, Jack, Bob Calder, Dave Neighbor, E.O., Kevin Parachan, Matt Sutter, Aaron Luthen, Flying Out, Christopher Rappin, Brendan Minish, Greg Briggs, Robert, Gary S., Marjorie, Rudy Garcia, Kurt Larson, Steve Leisman, Sean Lamb, Greg Riley, Jim Drapeau, Lisa Suzuki, Christopher Dreyer, Brian Carrington, Jason Olds, John McKee, Paul Artyom, Ulysses Adkins, Kevin Reardon, Noodles, Dave Wilkinson, Sue Doster, Paul Ronovich, Daryl Myshak, Dave Friedel, John Ratnaswamy, Stephen Alberon, Seth Agradney, Mountain Sloth, Rodney Lewis, Sarah Chavis, Corinne Benton, John Gridley, Jean Tellier, Patrick Pecoraro, Darwin Hannon, Matt Bass, Dan K, Farrah Forfar, Donald Mundis, Howard Tan, Josiah Zahner, Taylor P.S., Ben Bignell, Maddie Perrin, Ashley Doyle, Mark Hessenflow, John Atwood, Allie Coffin, Ben Rothig, and John Lee. Thank you for all of your support on Patreon. If you're interested in supporting us, you can find information at patreon.com/thisweekinscience. And on next week's show,
we will be back on Wednesday at 8 p.m. Pacific time, broadcasting live from our YouTube and Facebook channels and from TWIS.org/live.
Hey, you want to listen to us as a podcast? I bet you do. Sure. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, please get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twis.org. And you can also sign up for our newsletter there.
Hey, you can also contact us directly. You can email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put TWIS, TWIS, in the subject line or your email. It's going to get spam filtered into oblivion.
You can also hit us up on the Twitter where we are at TWIScience, at Dr. Kiki, at JacksonFly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes due in the night, please let us know.
We will be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought. And I'll try to answer any question you've got. So how can I never see the changes I seek when I can only set up shop 1 hour a week. This Week in Science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science. This Week